Hello and welcome to Netitude Labs. The purpose of this video is to demonstrate a new tool called Invoke-Pbind. Invoke-Pbind was created to overcome challenges in C2 communication in a well-segregated environment. The tool is almost a C2 framework in its own right, however has been released as part of PowerShell to extend its lateral movement capability. If we look at the code is written in PowerShell. It's deployed within the modules folder of PowerShell. We have a description, a number of parameters, and examples. The video accompanies a blog post, which if you've not read, we'd recommend you do so before continuing with the video. There are a number of execution methods. WMI and PSExec are both supported. Both can take either credentials or pass the hash. When a hash is set, we've also got to specify a second set of credentials, as detailed in the blog. The script creates a map drive connection to the IPC dollar on the target. Any domain user credentials can actually be specified, and these are passed through user 2, domain 2, and password 2. The script creates a unique AES encryption key every time an implant is to be started. It also specifies a pipe name where one has not already been specified. So a random pipe name of alphanumeric characters will be generated. And then we have a server script block and a client script block. The server script block is the implant that will run on the target. The client script block will either run locally on your workstation, if being executed locally, or through a C2 framework onto a compromised workstation that you've targeted and already have an implant on. The server script block starts a named pipe and then reads and writes to that named pipe to share information backwards and forwards with the client. Any commands that are passed to the server script block are then passed through to invoke expression, with the output of that being passed back to the client. The client script block, again, connects to the named pipe that's already been established. Both script blocks are self-executing. Further detailed in the blog is also the capability for additional flexibility in the deployment of the implant, and to support this we create an executable. The executable is created off CS# code, in which case we put the implant code here and then generate the binary. Now the binary is compiled using .NET Framework and CSC. It supports both 4 and 3.5. When creating a binary, we also have to pass the location of the System Management Automation DLL, as shown here. This supports the execution of the binary. When we do run an executable, we also want to know the details that have been hard-coded for that binary. So we'll output some details around the secret, the key, and the pipe name for the client. The execution methods for WMI and PSExec are both part of Kevin Robertson's WMI and SMB exec scripts. However, we've slightly modified those scripts to also take a password where Kevin's scripts only took pass the hash. However, we also support credentials and create an NTLM hash from the user credentials to pass the hash in the script. So I'll just jump further down. And the important parts here, as we mentioned, we're mapping a network drive. If it's a hash that's present, then we will pass the credentials, domain 2, user 2, and password 2 to map the IPC dollar on the target. This can be changed by just hard coding the script. We'll then utilize either PSExec or WMI exec to pass the payload onto the target. This is the injection of the implant into the target. The client is then executed in a run space, just here. And the reason for doing this is very specific. So within a C2 framework, and you've already got a compromised session, what we don't want to do is lock the session up to be tied into an interactive shell. So how we've got around that is actually to pass commands to a variable that's monitored by the script block. So we'll quickly have a look at that. So we've got a global script block here called pipe state, and we can pass commands that are passed through the function pbind command to that pipe state.command variable, and then that is picked up by the client that's executing. It will then be encoded and passed across the pipe to the server. The server or the implant will then pick that up, decode it or de-encrypt it, unencrypt it, and then execute that in Invoke-Expression, re-encrypt the data, put it back on the pipe for the client to pick up. So if we go and have a look at the example, this is PowerShell 2. We have a shell already on the box. So if we do who am I, we should see a response from the client, or from the compromised workstation, and we should be Corin within Blurbank running on Win7 client 1. So we already know we've got an environment which we've got an IP address of a segregated box with administrative credentials. So we're going to invoke Pbind against the target, provide it some credentials to invoke itself, and as we're giving it credentials, we don't need to pass any secondary credentials. So kick that off now. We'll wait for this to respond. It should come back and say connected and provide the name of the pipe. As we didn't specify one, this will be a randomly named pipe. One thing that I do love about PowerShell 2 is that it automatically loads modules for you, so we don't have to load the module, Invoke-Pbind. We just give it a command, and if the command matches, it will go and load the module before executing. So we are now running. We have connected to the named pipe. So again, if we do who am I, we'll get a response which says we are Corin on Win7 client 1. However, if we do pbind-command, we'll pass a command to the global parameter pipestate.command, and it will be passed along the pipe. So we'll do who am I, pbind command who am I, and we should see that we are Ben, and then we'll further do host name. So commands can be passed quite quickly as they're just updating the variable. So sending command who am I, and we are Blurbank Ben. And now we'll send another command, pbind command host name, and we'll just see what host we're on. So at this point, if we actually jump onto the client, it's worth showing. So follow the TCP stream. We'll see that all data is actually connected over one TCP session and being exchanged with the endpoint. This means that there is no beaconing. It is inside one TCP tunnel, so we're only having one connection to the pipe. So the blue is the commands and the red is the response. Okay, so if we want to take this one step further, we talk about templates in the blog, and we want to execute a template. We've created a template quickly for an example. So pbind.ps. So what we do is we take pbind command, $ps equals, this is the full command that we're going to pass through, so obviously you can't write this and copy and paste might break. So we take that, that's a base 64 of invoke port scan. So if we just look at port scan, we've just base 64'd this whole script. We have a command, invoke port scan, provide a host, tell it what ports we'd like to do. So in our script, what we're going to do, so we're going to take the full command, we're going to pass pbind-command to dbase64 ps and pipe it into Invoke-Expression. This will then mean in the implant, we now have in memory also the full invoke port scan function or script. Then we can pass pbind command, invoke port scan host, provide it the details that you'd like it to scan. So this is another host within the environment. We're going to scan it for the top 50 ports. So again, let's jump back across. So we just need to do load module pbind-ps.ps1. It should load and auto-execute the 3 lines of the script, in which case we should then have the full output of a port scan against 105 from 100. not from the client here. So we have tunneled directly through, we're connected to a named pipe, and all information has been passed backwards and forwards on the named pipe. This is not bi-directional communication, it's a TCP connection that's been passed in one direction only. So port 445 would support this, and this is exactly why it was created. We can then laterally move to other locations within the environment and pass through additional scripts that will carry out, such like Invoke-Pbind exec or Invoke-SNB exec. We can pass those scripts through with shellcode embedded to inject those into memory on a target inside the environment. So you can see how this greatly assists NEC2. So we can see here the open ports 443, 3389, 445, 139, and inside that segregated environment we don't have any firewalling, so we can laterally move quite quickly. I think that's really all I wanted to show. Again, we can still show that we are still in control of our session and everything has been done in a run space, therefore we have an interactive session but it doesn't impact our actual session in C2. Okay, thank you very much.